Observing the ramp slope versus number of washers, there was a change in the ramp slope of 0.033 per 5 washers. Now this was just based on an observation of 2 data points. We put 5 washers and then 10 washers over the pulley and adjusted the slope. And we'll see the data in a minute. But when we did this, we found a slope of, this says 0.065. It should say 0.0065. I've got an unstable surface to write on here. That should be 0.0065 per washer. Now we had the following. We're not going to show the actual data. It was fairly straightforward. But when we had 5 washers, we attained a constant velocity on a slope of 0.0067. With 10 washers, the constant velocity was attained on a slope of 0.040. This is a change in slope between this point and this point of 0.033, which is of course the rise that we had on the graph over here. Now let's compare this with the 0.013 slope change per washer that was predicted by our previous data. Well, we got 0.065, we would predict a 0.065 slope change for a 5 washer difference. Okay? That is at 0.013 slope change per washer. If we had 5 washers, we'd have 5 times that, or 0.065 in slope change. And as we see here, the slope change that we found is only 0.033. So there's a significant and troubling discrepancy between what we found, the 0.033, and what we predicted, which is almost twice that. I'll point out that the data that we had before was from one group. There could be an error in that data. You might go back and compare what you would get, what slope change you would predict per washer based on a slope of 980 centimeters per second squared on an acceleration versus ramp slope graph, and a slope of 6.8 centimeters per second squared on an acceleration versus number of washers graph. If you understand the process, you could go back and recalculate this, and that's something you should certainly do.